Hello, my name is Andrew Beachko, and the purpose of this video is to explain what a neural network is and how it works to assist with a paper that I'm writing for a tutorial on how to create a neural network. So to start off, what is a neural network? And to understand this concept, first you need to know its namesake. Neural networks are named after the neurons in the human brain. And what happens whenever you see a thought or whenever you have an idea, a chain of synapses between a bunch of different neurons trigger, all coming towards some conclusion. So neural networks are based around a similar concept to where you have a lot of different inputs or neurons, and they are linked to other neurons and chain linked down and down, each one kind of adding its own value and twisting the information to hopefully come to some conclusions. Now, for neural networks, what are neural networks made of? You have, for a basic neural network, for example right here, you have an input layer, which is usually a list or array of data, and it could be anything from a spreadsheet of numbers to an image with it, which is just a matrix of integers that could be displayed here, or any other kind of thing, like measurements between animals. And what you can have is that for each one of those measurements, you can have a node, and it links up to a center node area, which is linked by a bunch of different weights. So you have all these inputs going towards the center nodes, and then from the center nodes, it goes outwards. And then as it goes out, it will give you the likelihood of it being any one of these options. So if you were given the, like, say, weight of an animal, the height of an animal, and how many calories an animal consumes, you can pass those numbers through a neural network, and based on probability, or like based off of different weights to different datas or different sections of data, it can give you the likelihood of it being any one of the output options, a cat or a mouse. So that is the basics of how neural networks tend to function. But if we want to look more into how they actually forward propagate, we have this right here, which is the forward propagation. So for every node right here, it has two main mathematical functions. There's a summation node and there's a sigma function. So for every one of these nodes, the first step is taking all of the values of the previous nodes, multiplying them by the weight associated with them, and adding them together. So that is step one for every single one of these nodes. After that, you will get some form of integer number, or some form of number. And after that, you can put the result through a sigma function. Now what a sigma function is it is a graph shaped like this, and it is 1 over 1 plus e to the negative x. But what is the purpose of this? What happens is if you input an x and you get a result on this graph, you end up it ends up being plotted somewhere along this line. And if you have a number that will be plotted up here, that means that the result of this node means that it is very, very certain that this input is true for whatever the result is. So it'll get a really high true. Or if it's very, very low, it'll say, no, I'm pretty sure that this is a false statement, or somewhere in the middle, not sure. And it's more easy to see right here, because if you have all the data processed through, and you will end up with each one of these nodes saying, oh, I'm pretty sure it's not a cat, I am very sure it is a mouse, and from there you can choose whichever node has the highest certainty. That is how neural networks work, it's a huge list of certainties of whether or not that statement is true, and the true answer for the neural network is whichever node has the highest certainty. Like, I am the most sure that it is a cat. And that is how the sigma function works. It gives you a probability based off the input data. And then you do this for every single node. So it kind of chains through. It does it for this node, then this node, then this node. Then all the results of these nodes are repeated for all the answers. You can have multiple layers. You can have more nodes, more inputs. Same kind of process. So that is the forward propagation on how it processes data. And that is how, if you have a fully trained neural network, you give it a brand new image, it propagates through and it tells you which one it is most likely to be. But this is machine learning. How does it learn? And that is the backwards propagation function, which is right here. So, reason why we talked about forward propagation first is because forward propagation is the first step of backwards propagation. So, with backwards propagation, how you learn is you are given a bunch of test data where you already know the correct answer to it. And what you do is that you take the test data, you run it through your program, your neural network first, and based off of the results of that neural network, you compare it to the correct answer. And then you get the how off it is, the error compared to your output to the actual correct answer. Then what you do is that you kind of chain backwards, you kind of work backwards from these nodes. You kind of like start right here and you modify the weights going here, and then you take the result, modify the weights here, 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 based off of all the inputs. So you adjust the weights. The formula is you adjust the weights by, you have the error times whatever your input is times the current value times 1 minus the current value. That is the learning formula that I have been using for creating, when I first tried to create a neural network. For the example paper I'm using TensorFlow. So all these calculations are pretty much done for you, and it is very, very easy. The only reason why I'm kind of talking about these calculations is because it's good to know what goes on behind the scenes instead of just blindly using tools without knowing how they work. So you have the error times the input, and then this value is how each weight is changed along the neural network, and this kind of chains backwards. So for inputs, this is a little bit ambiguous for some people because what exactly is an input if you're going in reverse? For the first node, for these input nodes, the input is actually the correct answer. So you can think of it as, if this is a correct answer going here, that is being the input right here, times the current value of this output, or times the current value of this output, which would be x. So you have that times the error, and then that is how much this weight will be adjusted by, and this weight, and this weight, and this weight. And then when you get to the center nodes, the input would be the results of right here times everything else, and it kind of chains backwards like that. So that is effectively everything that there is to know about neural networks. You do forward propagation by taking an array of numbers, chains through, and gives you an array of likelihoods of each of the answers being correct. And then how it learns is it takes those answers, compares it to already known correct data points and data answers, and it chains back and kind of adjusts all of the weights as it chains back. And the reason why this is important is because for most people, when they create a neural network, all of these weights are randomly generated numbers, and how they actually get the neural network up and running from randomly generated numbers is just having a huge but like a whole set of test data with the correct answers and constantly sending it through and training it backwards, adjusting the weights, and after a certain amount of time, the weights are all adjusted to be fairly accurate for whatever image you're going through, usually to up like 95% and above accuracy for all of these. So that is the gist of neural networks, and hopefully you enjoy the rest of the paper and it's clear and walkthrough.